Today you're going to be taking notes on the real number system. This is the worksheet that you received in class today, and you'll be asked to take your notes on this worksheet. Please go ahead and complete this as we go along, and we'll go over it at the end to make sure that you received all the key points on this worksheet. What we're going to talk about, as I said, is the real number system, and there's different categories within the real number system. The first set of categories within the real number system are what we call natural numbers. These are the numbers that you naturally started counting as a small child. These are the numbers that we learned as a little baby. So the very first thing that you count generally are our natural numbers. They begin with 1. You know, as a small child, they start with 1, 2, 3, and count on from there. So anywhere from 1 all the way on up. You can see this arrow says that it continues. So 1 all the way up to infinity. Those are all what we call natural numbers. Next, from natural numbers, we learned that you could have nothing. As a matter of fact, the Aztecs were one of the first people to actually understand the concept of nothing. You would think it might have been the ancient Chinese or the ancient Egyptians or the Greeks, but it was actually the Aztecs that realized that 0 is a very complex thing to understand, the concept that there's nothing there. And they were the ones to actually come up with this idea of 0. So you wouldn't think that just adding a 0 onto something makes a whole set of numbers, but it does. And we call those the whole numbers. The whole numbers are 0 and all of the natural numbers in addition to that. Next, we have positive and negative temperatures. We have positive and negative sea elevations. And so we need to represent something that goes below 0. And that's what we call our integers. But integers just aren't negative numbers. Integers are positive and negative numbers. If you look at any number line in any of the math classes that you've ever had, especially in middle school, it represents positive and negative numbers. And those number lines show integers. So for instance, I could write ... -2, -1, 0, 1, 2, ... And of course those dots represent that it keeps going on and on and on. So integers not only are positive, but they're also negative numbers. But you see the number line, and you also see that it doesn't represent any of those numbers that are between the integers, the fractions that are between the integers. So we need a next number system, a next set of numbers to go ahead and identify those ratios. The ratio is basically a type of number that can be set up in fraction form. So we call those rational numbers. The root word in rational is ratio. That means any number that can be set up with a numerator and a denominator is a rational number. So that also means that 2 can be set up as 2/1. That's a rational number. So rational numbers include all the natural numbers. They include all the whole numbers. They include all the integers, as well as all of the rational numbers as well, positive and negative fractions or decimals. Now we need to go ahead and give all of these a name. And again, we call these the rational numbers. But there's a set of numbers, there's a set of numbers that aren't included in our rational numbers. And I like to call them the big, ugly decimals. One thing that I didn't discuss when I was talking about rational numbers are that rational numbers not only are fractions and decimals that terminate, and that means that it's a decimal that comes to an end, like 0.25. That stops. It doesn't go past 0.25. but also decimals that repeat. 0.6 repeating. That's a decimal that continues on and on and on, but we understand that it's the 6 that continues on and on. There's also decimals, though, that make no sense at all, and I like to call those the big ugly decimals, and those are considered irrational numbers. It's a fraction that continues on and on, but you really don't have a sense of what the next number would be. For instance, the square root of 2. If you were to put that in your calculator, you would see it's a decimal that continues and goes on forever, but really has no clear pattern. Also, we could put in pi in our calculator. Again, that's a decimal that continues on and on with really no clear understanding of what the next number is. Now we need to go ahead and identify all of these numbers, all of these sets of numbers, rational, integer, whole, natural, and irrational. Those are all part of what we call the real number system. All of those are what we call the real number system. So then, there's a set of numbers that just don't really agree with any of it. And we call these our complex numbers. For instance, if you were to go ahead and put in -4 on your calculator, and we'll practice this in class, and hit the square root button, your calculator is either going to say error or come up with an I. We call these the imaginary numbers, because remember, the square root of a number means, for instance, the square root of 16 means 4 times 4 is 16, or the square root of 4 means 2 times 2 is 4. But at the square root of -4, with our rules with integers, there's really not a number that we can say. So we call that number imaginary, and we call those complex numbers as well. So let's go back to here. Let's first start by identifying. In here, we start with our natural numbers. We have our whole numbers. We have our integers. And we have our rational numbers. Rational numbers encompass all integers, whole numbers, and natural numbers. And then we have our irrational numbers. All of these are part of the real number system. All of these are part of the real number system. Then over here we have our imaginary numbers. And I go ahead and I generally represent that with a cursive letter I. So let's go down here. And what I'd like you to do is to put in, it has set, symbol. The symbol is, it sounds weird that rational bit would be represented with the letter Q, but that's actually how we represent these different number systems, like integers with a Z, whole, W makes sense, natural, M. But these are just symbols that you could possibly see on a test to represent these different type of numbers. What I'd like you to go ahead and do is to identify members. That means an example of this number in that set. For instance, natural or counting numbers. I'll go ahead and give you an easy example. We could say 1, 2, 3, 20, 100. There's a number of different examples. What I'd like you to do at this time is to go ahead and put in those examples now. Thank you.